We will now see how to write AP by using the first term and the common difference. We know that the sequence 1, 4, 7, 10 and so on is an AP with 3 as a common difference D. In this sequence, the first term T1 is given as 1. Let us denote the first term as A. Therefore, we can write T1 is equal to 1 is equal to A. How do you write the second term 4 by using the first term? The second term 4 can be written as 1 plus 3, which is nothing but A plus D. How do you write the third term 7 by using the first term? The third term 7 is equal to 1 plus 6. It can also be written as 1 plus 2 into 3, which is nothing but A plus 2D. Similarly, we can write the fourth term 10 as 1 plus 9. This is same as 1 plus 3 into 3, which is nothing but A plus 3D. Therefore, we get T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, T4 is equal to A plus 3D, and so on. Thus, an AP can be expressed as A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the common difference. This is known as the general form of an AP. Hence, an AP can be formed by using its general form if the first term A and common difference D is given. Let us now solve an example. Write the first 5 terms of an AP whose first term A is 5 and the common difference D is 2. The general form of an AP is A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. We know that T1 is equal to A and it is given as 5. T2 is equal to A plus D, which is equal to 5 plus 2, which is equal to 7. T3 is equal to A plus 2D, which is equal to 5 plus 2 into 2, which is equal to 9. T4 is equal to A plus D, which is equal to 5 plus 3 to 2, which is equal to 11. And T5 is equal to A plus 4D, which is equal to 5 plus 4 into 2, which is equal to 13. Thus, the first 5 terms of an AP with the first term 5 and the common difference 2 are 5, 7, 9, 11 and 13. General term of an AP. We know that the general term of a sequence is its nth term Tn. In the same way, the general term of an AP is also its nth term Tn. We know the general form of an AP is A plus D, A plus 2D, A plus 3D, and so on. Therefore, T1 is equal to A. T2 is A plus D. This can also be written as A plus 2 minus 1 into D. T3 is A plus 2D. It can also be written as A plus 3 minus 1 into D. T4 is A plus 3D, which can be written as A plus 4 minus 1 into D. In the same manner, how can you write T5? T5 can be written as A plus 5 minus 1 into D. Now what will be Tn? Tn should plus n minus 1 into d. Tn is equal to a plus n minus 1 into d is the formula for the general term of an AP. Show that the sequence 3n minus 7 is an AP. Find the first term A and the common difference D. Also find the sixth term. Tn is equal to 3n minus 7. Therefore, Tn plus 1 is equal to 3 into n plus 1 minus 7 is equal to 3n minus 4. Therefore, common difference D is equal to Tn plus 1 minus Tn is equal to 3n minus 4 minus 3n minus 7. On simplifying, we get 3. 3 is a constant for all natural numbers n. Therefore, the sequence 3n minus 7 is an AP. For the first term, substitute n is equal to 1. T1 is equal to 3 into 1 minus 7 is equal to minus 4. Hence, A is equal to minus 4 and D is equal to 3. For the sixth term, substitute n is equal to 6. T6 is equal to 3 into 6 minus 7 is equal to 11. Example. Prove that a plus b, comma a minus b are in arithmetic progression. Solution. Here, second term minus first term is equal to t2 minus t1, which is equal to a minus a plus b, which is equal to a minus b, which is equal to minus b. Third term minus second term is equal to t3 minus t2, which is equal to a minus b minus a, which is equal to a minus b minus a, which is equal to minus b. Thus, the common difference between any two consecutive terms of the progression is a non-zero constant minus b. Therefore, the given terms are in AP. The second method is as follows. T1 is equal which is equal minus to a minus equal minus is equal is. Thus, it can be said that the common difference, therefore the given three successive terms are in AP. Unit 5.3, nth term of an AP. We will now derive the formula Tn is equal to a plus n minus 1 into d. Consider the general form of an AP. A plus d, a plus 2d, a plus 3d and so on. T1 is equal to A. What is T2 minus T1? T2 minus T1 is A plus D minus E, which is equal to D. Since it's an AP, the difference between any two consecutive terms must be same. Therefore, T3 minus T2 is equal to D. T4 minus T3 is equal to D, and so on. What is the term before the n minus 1th term? The term before the n minus 1th term is the n minus 2th term, that is Tn minus 2. What is Tn minus 1 minus Tn minus 2? Tn minus 1 minus Tn minus 2 is equal to D. What is Tn minus Tn minus 1? Tn minus Tn minus 1 is also D. Here we have n number of equations. Adding all the n equations we get T1 plus T2 minus T1 plus T3 minus T2 plus T4 minus T3 plus so on up to plus Tn minus 1 minus Tn minus 2 plus Tn minus Tn minus 1 is equal to A plus D plus D plus so on up to plus D. What is the sum of all the D in the right side of the equation? It is n minus 1 times D. The right side is A plus n minus 1 into D. By cancelling the common terms, what will you get in the left hand side? We get only Tn. Therefore, Tn is A plus n minus 1 into D. Thus, the nth term of an AP with the first term A and the common difference D is Tn is A plus n minus 1 into D. We can find any term of an AP by substituting the value of n in this formula. Let us solve a few examples by using the formula Tn is equal to A plus n minus 1 into D. Find the 25th term of the AP 12, 16, 20, 24 and so on. First, we have to find D from the AP. It is given that the first term T1 is equal to A is equal to 12. The second term T2 is 16. The third term T3 is 20. The fourth term T4 is 24 and so on. Therefore, the common difference D is T2 minus T1, which is 16 minus 12, which is 4. We know that Tn is A plus n minus 1 into D. Substituting n is 25, A is 12 and D is 4, we get T25 is 12 plus 25 minus 1 into 4. On simplifying, we get T25 is 108. If the 25th term of the given AP is 108. Let us solve another example. Find Tn for an arithmetic progression where T3 is 22 and T17 is minus 20. We know that Tn is A plus n minus 1 into D. Therefore, T3 is A plus 3 minus 1 into D, which is equal to A plus 2D. But it is given that T3 is 22. Therefore, A plus 2D is equal to 22. Let us denote it as equation 1. Now, T17 is A plus 17 minus 1 into D, which is equal to A plus 16D. It is given that T17 is minus 20. Therefore, A plus 16D is minus 20. Let us denote it as equation 2. By solving these two equations, we can find the value of A and D. Subtracting A plus 2D is equal to 22 from A plus 16D is equal to minus 20, we get 14D is equal to minus 42. Therefore, D is minus 3. Substituting D is minus 3 in A plus 2D is equal to 22, we get A is 28. Thus, we have found the values of A and D. We can get Tn by substituting A is 28 and D is minus 3 in the formula. Tn is A plus n minus 1 into D. Therefore, Tn is 28 plus n minus 1 into minus 3, which is equal to 28 minus 3n plus 3, which is equal to minus 3n plus 31. Therefore, Tn is minus 3n plus 31. Let us solve one more question. How many 3-digit numbers are divisible by 4? In this question, we have to find the number of 3-digit numbers which are divisible by 4. That means we have to find the value of n. The 3-digit numbers which are divisible by 4 are 100, 104, 108 and so on up to 996. Here the first term T1 is A is equal to 100, T2 is 104, T3 is 108 and so on till Tn is 996. We have to first check whether the given sequence is an EP. Here, T2 minus T1 is 4, T3 minus T2 is 4, T4 minus T3 is 4 and so on. The difference between any two consecutive terms is the same. Therefore, the given sequence is an EP. Now, the first term A is 100. The common difference T is 4 and Tn is 996. We have to find the value of n. To find the value of n, we will use the formula Tn is A plus n minus 1 into D. Substituting the given values, we get 996 is equal to 100 plus n minus 1 into 4, which is 100 plus 4n minus 4. On simplifying, we get n is 225. Therefore, there are 225 3-digit numbers which are divisible by. If 5 times the 5th term of an AP is equal to 9 times the 9th term, then show that the 14th term of the AP is 0. Let the first term be A and the common difference be D. Tn is equal to A plus n minus 1 into D. Therefore, T5 is equal to A plus 5 minus 1 into D is equal to A plus 4D, and T9 is equal to A plus 9 minus 1 into D is equal to A plus 8D. As per the given condition, 5 times the 5th term is equal to 9 times the 9th term. Therefore, 5 into A plus 4D is equal to 9 into A plus 8D. On solving, we get A plus 13D is equal to 0. Also, T14 is equal to A plus 14 minus 1 into D. is equal to A plus 13D. Therefore, T14 is equal to 0. For an AP, Pth term is Q and Qth term is P. Then prove that Nth term is P plus Q minus N. Let the first term be A and the common difference be T. Here, Pth term is equal to Q. Therefore, Tp is equal to Q. Therefore, Tp is equal to A plus P minus 1 into D is equal to Q. Therefore, A plus P minus 1 into D is equal to Q. Equation 1. Now, Qth term is equal to P. Therefore, Tq is equal to P. Therefore, Tq is equal to A plus Q minus 1 into D is equal to P. Therefore, A plus Q minus 1 into D is equal to P. Equation 2. Now, subtracting equation 2 from equation 1, Q minus P is equal to P minus Q into D. Therefore, minus P minus Q is equal to P minus Q into D. Therefore, D is equal to minus 1. Equation 3. Now, taking D equal to minus 1 in equation 1, we have Q equal to A plus P minus 1 into minus 1. Therefore, Q is equal to A minus P plus 1. Therefore, A is equal to P plus Q minus 1. Equation 4. Now, Tn is equal to A plus N minus 1 into D. Tn is equal to P plus Q minus 1 plus N minus 1 into minus 1 is equal to P plus Q minus N plus 4. Tn is equal to minus N. If term the N plus then 1 twice term. Here, for the N plus 1's twice 1 term, N equal plus minus 1 N doesn't T 3 is equal as 1 of N D 3 6 N D. T is equal to 4A plus 6 ND. T M A plus